Hello everyone. Our team, the Revelers, represents St. Xavier's College, Maitikar. As the topic suggests, our project's central theme is the use of centralized intraledger hyperpermission blockchain technology, abbreviated to CIHP, to revolutionize national currency in Nepal. There's a saying, if it ain't broke, don't fix it. So why are we suggesting that there is a need to revolutionize the national currency in Nepal in the first place? What's wrong with the current state of affairs? What can be done about it? What does the model of the proposed system look like? How is it governed? What are the risks involved? And finally, how do all of the elements and parties come together to materialize the idea of a centralized, modular, and permission blockchain? These are exactly the questions that the rest of our presentation and our project as a whole intends to answer. Let's take things one at a time, starting off with the opportunities that underlie the problems and how our proposed model intends to solve them. The problem with present day currency in Nepal is that it is largely unregulated, as a direct consequence of which Nepali rupiah is vulnerable to inflation. Such ill fate can be brought upon by large amounts of national and foreign currency departing and entering the country without any regulation whatsoever from a central Nepali authority. Moreover, the chances of occurrence of illicit transactions such as money laundering is alarmingly high in the absence of such regulatory practices. For an everyday user, our new model of currency provides enhanced transparency as to the status of the transacted amount at any given time. Finally, the latency issues which might be faced by a conventional digitized currency making use of blockchain technology is circumvented by our approach via the use of an authorized network of tertiary third parties to gain consensus and the use of Byzantine fault tolerance algorithm to prevent Byzantine fault error. We have named our approach to solve these problems centralized intraoperaledger hyperpermission blockchain, henceforth referred to as CIHP, which cleverly employs the concepts of centralization, interoperability, modularity, configuration transparency, and permission blockchain to bring into fruition a centralized digital currency exempt of the aforementioned problems of regulation, security, and lack of transparency that present day Nepali currency faces. Moving on to the particulars, let's take a look at architecture of the proposed model. At the heart of our model for digital currency lies CIHP, our modular, interoperable, efficient, and permissioned approach to a virtual money that enjoys benefits such as forklessness, low latency, and decentralized regulation. Here you can observe the intricate network of parties and elements involved. To understand the architecture of this model, it helps that we understand the various terminologies and elements that contribute to its constitution. Each of the following slides will be accompanied by a diagram which can aid in comprehension. Let us begin with interoperability. Interoperability is a property of similar systems which allows them to be used interchangeably. This property is attributed to the metadata registry system, which also provides the added benefit of removing ambiguity. Next up is permission blockchain, which employs a pool of vetted participants to gain consensus. Such a proposed permission network is highly modular, configurable, and scalable in nature. To eradicate Byzantine fault error in such a system, delegated proof of stake along with Byzantine fault tolerance is made use of. The benefits of permission blockchain system include low latency of transaction confirmation, compatibility with pluggable consensus, and flexible approach to data privacy. Staying under the wide umbrella of architecture, let us now turn our focus to centralized delegated proof of stake alongside off chain storage. The former refers to a system whereby a set of entities accredited by the central bank are made responsible for the creation of blocks. In such a system, the central bank verification committee confirms the block hygiene and appends the verified block into the permission blockchain. The off-chain storage system addresses the security and performance-related issues that burden an on-chain data storage system by using parallel hashing. Speaking of hashing, a Merkle tree is a hash tree used for data authentication and synchronization. The use of a Merkle tree shuns the problem of having to download the entirety of the block into one's memory just to check one's own transaction details. It accomplishes this feat via the use of a sibling search mechanism, which expedites the process of searching up a desired transaction exponentially and also helps trace the desired transaction record via the Merkle root of the tree.
Now let's briefly talk about how the whole system works and the governance structures that are set behind it. It all starts when a user requests for a financial transaction to be validated from the node banks. The request could be transactions related to money transfer, loan request, withdrawal, etc. Basically, any transaction that the current banking system allows its users to conduct. The node banks, who act as the validators in this system, verify the integrity and the logistics of the transaction before the transaction block is formed. Our system implements the concept of delegated proof of stake system, which I will be referring to as DPoS from now onwards. DPoS eliminates the need for intensive computational mining that is inherent to other proof of work protocols. DPoS features an extensive delegation system, and that makes it one of the most democratic and decentralized protocols that we could implement. In our case, the central bank is authorized to delegate node banks periodically. The number of delegates that are chosen varies depending on the size and the span of the blockchain network. The delegates verify the transaction and set the block parameters such as block sizes, block intervals within the network, etc. The delegated banks now move on to the block formation process. For a transaction block to be successfully formed, it needs 51% consensus from the node banks. Moreover, because our system is a distributed computing system, there's undoubtedly a chance for Byzantine fault. To eradicate it, we have used BFD or Byzantine fault tolerance computers. This removes the chances of those false, dishonest errors detected in the system to completely shut down the transaction process and thus enables the delegates to come to a joint decision much easier. After a block is formed, it needs the approval of the central bank before it gets added to the blockchain system. Central bank's approval also acts as a second layer of verification of the transactions. Now, users can access the blockchain network to view their transaction blocks by signing into a login portal, which is predefined by the central bank. All of the mentioned processes are always under the control of the central bank. Now, let's briefly talk about the governance structures of our system. For any prototype plan or proposal with enough potency to bring reformation, having proper governance structures set up is crucial to ensure trust, transparency, control, and coordination among the involved parties. Furthermore, governance structures help to define a comprehensive set of rules and protocols for the design, development, and deployment of a plan, consequently helping to mitigate risks, facilitate a smooth operation, and avoid conflicts. The governance structure of our proposed plan is divided into three important sections: the IT infrastructure, the network membership governance, and the business network governance. We believe properly defining the governance structures helps to address the political, legal, and economical issues that are to arise. Network membership governance is essential in order to supervise the management and governance of the involved network parties and services that constitute the system. Now, following is the list of protocols and measures taken to ensure proper governance within the network of parties. First off, we have proper communication policies set up to make sure that no misinformation is spread among the parties. This helps to make matters more transparent. Now, what about new memberships? Well, if a new node bank wants to enter the network, voting is done among the existing node banks, and final approval from the central bank is needed to add the new member into the network. For entities within the network, our system ensures that they have proper data ownership rights. Being a blockchain system at its core, our system allows the parties to view and retrieve the financial data stored in the permission blockchain. Our system allows confederation as long as it doesn't hamper the operation of the system. Users or node banks can form alliances sharing common goals and interests. We also have proper regulations and permissions set up for each type of party and future alliances. Finally, if a party fails to comply with the system protocols, we have legal penalties or retribution specified as well. The financial policies, protocols, and compliances for the network are taken care of by the business network governance structure. This helps to resolve potential economic disputes, regulate the flow of money, and monitor transactions based on a set of specifications. Our business model is a confederated model and comprises of three important parties: the central bank as the issuer authority, the accredited banks or the node banks as a verified authority, and the users as the account holders, thus completing the trust triangle of our system. We have several service level agreements or SLAs set up to ensure quality and security within our network. Our system has properly defined risks assessment and management policies to mitigate economical issues for the involved parties. For the financial contributions and the monetary incentives that each party will receive, we have specifications for them as well. Finally, we have security protocols to ensure integrity among the parties and resolve internal conflicts. On to the IT infrastructure governance. The IT infrastructure governance encompasses the rules, regulations, policies, and protocols related to the technologies required to deploy, operate, and update tenets of the blockchain system. Our system, CISP, is an implementation of blockchain technology with the use of smart contracts. The regulation is quasi centralized and the interoperability is assured. The system is a conglomeration of interconnected blockchain nodes distributed via P2P network architecture. For the stability of the technologies used in the system, we have policies and plans set up to make sure that the system remains up to date with the future technologies. The system also has rules specified to monitor attempts of tampering the blockchain and logging of issues for future mitigation of those issues. Lastly, our system is COBIT or COVID driven, which stands for Control Objectives for Information and Related Technology, which is an industry standard framework for managing the IT governance of systems like ours. That sums up the governance structures of our system. On to the next part.
Now, let's move on to the risks. Well, one of the most prominent risks associated with the execution of the proposed permission blockchain is that it cannot, yet, despite the centrality of science and technology in the 21st century, be implemented in the remote corners of the developing world, where, not infrequently, people do not have bank accounts or mobile phones. Another challenge is that the governments of nations lose an important alternative to pay for their debts, namely by printing two to the letter money. Furthermore, owing to the fact that the proposed blockchain system is quasi centralized, it cannot account for the poor execution or the abuse of the system's charter and policies by the issuer, that is, the central banks of the respective nations. Well, moreover, for the very poor people, many of whom do not have access to the banking system, the proposed model shall make them more dependent, in fact, exclusively dependent on the government handouts. Finally, as we conclude this specific portion, we would like to point out that although the central bank is the median entity that monitors and regulates the different facets of the technology proposed herewith, the accredited banks are as vital for the actual delivery of the services. And in this light, it would be a challenge to incentivize these accredited banks to deal with the administrative hassles associated with handling millions of very small cash transactions and related customer queries. Now, let's move on to the value proposition. Well, the greatest value of the proposed permissioned blockchain is that the users and the banks are greatly benefited by the improved capital optimization and instant settlements directly. Since the central bank is the only bank that is involved in or remotely monitors the transaction of the users, the operating expenses become low, because of which the users need not pay high commission to third parties involved, that is, the banks that have been funding the services till today. Furthermore, due to the increased transparency of transactions, money laundering and correspondent risks are minimized, financial optimization and mobilization are safe and secure. A point to be noted is that even in developing nations, in the last 5 years, we have seen a mushroom growth of companies and corporates in the digital payment industry. For instance, in Nepal, platforms like Isewa, Khalti, and Connect IPS have provided a promising avenue for online payment. There are many such initiatives in the developing world. However, the problem with being limited to such initiatives and modes of payment is that they do not offer international banking to the general population. Moreover, the charges of such private companies are high and they often maintain a monopoly in the regions they operate, often in the entire nation where they provide their services, as we have seen with Isewa in Nepal. The proposed digital currency is objectively better than such services and provides greater value to the general user. Now we move on to the distribution. Here, we'll highlight how the proposed technology shall be implemented. Well, First off, the ministry or the department that looks after the banking sector of a respective nation shall pass a bill regarding the proposed digital currency. Next, a wide range of people involved in blockchain shall work on developing this into software and tertiary banks. Say, for instance, that person A is sending money to person B. At first, person A locks in the protocol using his or her private key. Then, the transaction details, including the timestamp, the block height, and hashes, are stored in the blocks in the form of a ledger. The blocks are then chained publicly in the permission blockchain. Here, the tertiary banks shall be serving as the nodes in the proof of work. After the transaction is assigned to all these banks, provided that there is a 51% consensus that the transaction is valid, the transaction is added to a block on the chain. For the purposes of speed, the algorithm referred to as the Byzantine fault tolerance algorithm is used. The chain, then, is shared publicly, except for the users, with the help of the central bank's customized software. And even after public sharing, only the central bank's software will have the feature to decrypt the block into respective ledgers. If two people have accounts on two different banks, the different bank to bank transfers will develop different Merkle strings. Then the Merkle root of the blocks are dispatched to the respective users and banks. Well, thus, through the implementation of these procedures, the technology of blockchain can be used as a tool for faster, safer, and reliable banking transactions in the long run. The technology proposed herewith shall be a boon not just to the age of today, but even to our posterity and our safe tomorrow. Also, as we end, we'd like to express our profound gratitude to the IBCOL committee and great humility for this opportunity they have provided to students like us all over the world to express our ideas. From the bottom of our heart, thank you.